Let's see what is next. No, that's not it. Physics, electricity. Yeah. Right. Whoops. Capacitance and capacitors. So I know I don't need this anymore. Right, there you go. If you can write that down, that's our next topic. Okay, you wrote the title down? Yeah? Okay. Right. So, look at the following here. Let me explain this with my hands. What we have here is a cell, and these are two metal plates. Let me try and draw it actually here. So, you have, something like some copper, and then beside it you have another piece of copper, and importantly here they don't touch, so there's a small distance here, maybe something like 1 micrometer or 10 micrometers, small distance, okay. And then what you do is you connect this up. We'll give it a switch to be safe, and we'll have it connected up to some power here, and then we'll connect it to this plate. So what will happen is the current will move along here, and you might think that the current stops because it's broken, that it can't continue.
Because
it's not touching.
Conduct
yeah, because it's not touching.
Yeah.
But as long as there's a vacuum here, do you know what a vacuum is? What is a vacuum?
What does it mean?
Yeah.
The vacuum.
No air.
No air, yeah. The current can actually continue through to the next plate. But, well, it's complicated, and it's something that we'll do in semester 2. It is to do with a topic called fields, and that's something we'll do in the next semester. But for now, if the plates are close enough together, the current can continue.
Okay,
but what's happened, yeah?
But like the vacuum, it means no air.
Yeah.
So how the vacuum will be there and will transfer the electricity?
He just asked me that. He just asked me that. And what did I say to you? Semester 2.
Is there a particular...
I'll explain.
Okay.
No. It just needs to be close. Small distance. So, the current can continue. But what happens is that the plates become charged. So, this plate will become positive and this plate will become negative. That
So they can attract or go...
They want to attract, yeah. So I suppose you have to make sure that they don't touch each other. Okay. So usually this might be in something like a glass box or something like this. So it doesn't touch each other. So this plate becomes positively charged and this plate becomes negatively charged. So you know from chemistry as well, if it's negative, that means there's more electrons here.
More than protons.
More than protons. And then the opposite is true here. You are missing electrons. Yeah. So the electrons basically they collect onto this plate. They build up. Now,
How come they don't attract them if it's metal?
yeah, that's why you need the glass case, because if they're oppositely charged, they want to pull together. Yeah, so you need like a glass case or something. You need to keep them fixed in place. Now, what was really interesting then is if I remove the power, I keep the switch closed, the current, it doesn't stop, it continues. Doesn't continue forever, but for a small time, the current will continue. So what has happened is some charge has been stored here, and then even though the power is gone, you can still have some current, but the current decreases. It doesn't last forever. Okay? This is the basic idea of what a capacitor is. A capacitor can hold the charge and it can release it later. Now wait, please, it's not like a battery, because a battery, it makes the charge continuously, whereas a capacitor, it just holds the charge temporarily and then it can release it later. Okay, so a capacitor is an electronic device that stores electrical energy or charge.
I've read all of this. Also called, also,
Nah, you don't need to. Nobody says that anymore.
okay, so I've read is an electrician.
Yeah. Iyad, can you just adjust the focus? I think it's a tiny bit blurry. Thanks. Just
Alright.
I don't know. No, but good. Yeah, that's
Yeah.
nice. Yeah. Okay, you got that?
Yeah.
Some capacitors can hold more charge than other capacitors. So we need a unit to measure how much charge the capacitor can hold. So, if you, for example, have 1 volt, and if the capacitor can hold 1 coulomb when you have a 1 volt, then we say that the capacitor can hold 1 coulomb per volt. So if I then put in a second cell, and it's now another volt, then this can now hold, it could hold 2 coulombs. So now we have 2, well, we still have 1 coulomb per volt, because we have 1 coulomb from this one and 1 coulomb from this one. In total it's 2, but it's still 1 per volt. Yeah. So it's like 2 coulombs divided by 2 volts. It's still 1 coulomb per volt. So this coulomb per volt is a new unit. It's called capacitance, and it's basically the ability to hold the charge. And the unit is called the farad, but a farad is just charge divided by volt. It's basically a coulomb, 1 coulomb of charge, that should say held, not helped, held per 1 volt. So 1 farad is 1 coulomb per volt, and the capacitance is the charge divided by the voltage. 1 farad is 1 coulomb per volt. Okay, so you need this, please. And I actually need to change help to held. Let me just change this here. Held. Okay. Okay, you have this. You wrote all of this down? Yes? All of it? Okay, good. What happened here? Why? You didn't like it? What did you call it? Mechanics, was it? Okay, you have this? Yeah? Continue?
Yeah.
Okay. Right. Here is an old example of a capacitor. So what happens here, if you maybe see them in movies, when you press the button, you have to wait some time, and then you get the flash.
Yeah.
What's happening in this camera? Stored. So you have the battery, and then there's a capacitor. So what's happening is the charge is building up here, and then once the charge is big enough, then it's released. I suppose I could. Yeah, actually, you know what? I'll show you how to. I'll draw the circuit for you. Let's think. So we have a power, and then the power charges the capacitor, and there's a switch here that goes across like this. And then what happens is, here's the light here. So in the beginning, the current will go along like this, and this will build up and get a charge. Then when this is big enough, when there's enough here, what happens is this switch flicks down to here. So this is gone. And now the current, there's no battery anymore, so now the current is released from the capacitor, and then the flash goes off. So this is a small battery, and then over a few seconds it charges this capacitor, and then when this has enough energy, it's released into the light bulb, and that's the flash then. So I think actually this might be a useful circuit to draw. This is how you might charge and release energy. So first it's in the up position, and then second in the down position here. So I think you should draw this. It's a useful, simple circuit. So this could be a small e, and then this could be a large charge. Okay, you drew that? Yep.
Yes.
Okay. There are other examples of devices that use capacitors. Can you think of anything else that might use a capacitor?
Laptop.
Huh?
Laptop.
Laptops do use capacitors, but
Watches.
they use them to,
And the charger.
yeah, but they use them for a different reason. I want a capacitor that is used to charge up to release a big amount of
Light.
energy. No.
There is a light.
No. Yeah, but
The old one.
Like a power bank, maybe?
yeah, but okay, you're not quite getting what I'm looking at here. I'm looking for something that needs to charge for a few seconds and then release a lot of energy quickly, like the camera flash.
Okay. 1 second. The vacuum that we clean.
No. Because if you vacuum, right, it doesn't go like this. You don't go on, wait. You know, you want something where it charges and then all of a sudden the energy is released.
The car when it does boom.
No.
And then
You don't? No?
no.
Generator?
Yeah, I was just thinking that.
This?
This is when they put on the
Yes?
somebody's body.
Yes? So the capacitor charges and then it's released. Okay? So these are examples of capacitors. Okay? Right. So here is an example that we'll do. A flash camera has a small capacitor. When you press the button, the capacitor charges up until a flash happens. The value of the capacitance is 1500 microfarads and the voltage is 380. I don't know why I made the voltage so large if it's a camera. It should be something smaller.
Maybe 110. This is nice number.
I don't know. That doesn't matter. How much charge is held in the capacitor? Okay. I've only given you one formula for today.
Yes.
1500 what, sorry?
Microfarads.
So it will be Q over V.
C equals Q over V.
Yeah.
And I want the Q. So Q
Okay.
equals...
So 1
Yeah.
5 1
Yeah, don't say anything. Write it down. Do it.
Micro how much?
Oh, come on, Mayor. You know how much micro is. How much?
-6.
Yes. Don't break my heart now. Come on. You got it? You got it? Now, what's the unit for that answer?
No.
Cool, cool.
2 more.
So, let me see. Come on. Right. So, C equals Q over V. What did I want? Q, isn't it? Equals CV. So, Q equals 1500 micro. And the voltage was 380. So, you got 0.57 and the unit? Coulombs. Fuang,
Yeah.
give me the answer in millicoulombs. What is it? No. Do it in your head. Yes.
Multiply 10 minus 3.
Just give me the answer.
0.005.
Anybody want to give me a millicoulombs?
570.
570 millicoulombs.
Oh.
Oh, yeah.
Right. I will just tell you that in these topic, because we're usually dealing with small numbers, it's very common to use millicoulombs and microfarads in the exam. Okay, so please note milli and micro are common in this topic. Okay?
Yeah.
Next.
But I think you
No, I know you can. I just was being mean. Alright. Right, so now let's have a look at how we can combine capacitors, because of course we could have situations where they're in parallel. So,
But I have one question.
yeah,
Okay, when we know that when we will divide it and when we will multiply.
no,
What no?
no, no. I have talked too much about this. Haven't I,
Yeah.
Mayor? Yes? I'm not going to explain again, I'm sorry. You have to watch the video. Because Mir asked me this, didn't you?
Yeah.
Yes?
One.
And
Yeah.
someone else asked me it as well. You asked me it as well, yeah?
That's too much. No.
Let's watch the video.
Yeah, yeah. I've done it too many times now. Too many times. Okay. Capacitors in parallel. So this one is C1 and this one is C2. And we want to know what it would be in total. Okay. So when they're in parallel, capacitance adds. So the total capacitance will be C1 plus C2. Can you make note of this, please? Mahmoud,
Yes.
did you re-watch the first video from the first lesson
Which
when you did the first homework? The very first lesson in mechanics. No, why?
No. No, but I saw
You
the
redid
link
the
one.
homework.
What?
Oh, please, give me strength. You redid the mechanics homework last week, remember? Yes, and did you re-watch the videos?
No, I saw the video of the electricity.
Right. You should re-watch the mechanics videos,
Okay.
especially the first one about the units.
Yes, okay.
Okay. Right, next. Remember that the voltage stays the same? You remember? Here, V1 and V2 are the same, yeah?
Yeah.
So, what's the formula for Q? It's equal to C V.
Or C1.
Yeah, so Q1 would be C1V, and the V here and the V here is the same. And Q2 equals C2V. Now, if you look here, the Q is equal to CV. What's the C? C1 plus C2V, which is equal to C1V plus C2V. But what's C1V? It's Q1.
Yeah.
So in other words, my point is that the charges, they also add. So Q equals Q1 plus Q2. So my next point is that the charges add as well. Okay? If you can make note of that. Q1 and Q2 add also. You don't need, you can write down my little proof here. Sorry, it's kind of spread out here. This is my proof. Actually, I suppose.
Like a proof.
Yeah. This is the proof here. Yeah, so I did this first and then I did this second. So I end up with this result. The charges add. Okay, is that okay?
Yeah.
That's not too bad, is it? So of course, what are we going to look at next?
Series.
Yeah, if the capacitors are
Yeah.
in series. Yeah. So, is there anything else for parallel? No. Okay, series. So what's interesting is in series, they add together using the formula 1 over C equals 1 over C1 plus 1 over C2. This is how the capacitance combines in series. So please note this.
sent me an email to visit university and saying that attend event. It says places are full. I mean, they sent me the email at 10:33, and then suddenly I did an email from the school.
You sent an email at 10:33.
Yeah, they sent me an email
At 10:33.
to attend the event, and at 10:35.
It's full?
Yeah.
The main of the university.
Yeah.
You had 2 minutes, was it? Yeah. Well,
Everyone was in the class.
minute, was
Yeah.
it? And what were you applying for?
I'm applying for civil.
Are you going then?
No,
Are you thinking of me?
no, not that. I will Limerick and
Go
Well,
away, yeah. Same.
Yeah.
first come.
Okay, so we have capacitance added together using this formula. Okay. So the next one is, remember that the voltage is different and it adds. So for example, I'll do it in red. If this is V1 and this is V2, then what's the voltage here? V1 plus V2. So let's look at what the charge is. The Q, what's the formula for Q? It's CV. Now, do we know what the C is? We have to calculate it from this.
Yeah.
But we know what the V is. What is it?
V1, V2.
V1 plus V2. Yeah? Now, this is kind of a little bit messy, but anyways, do I want to do this? Okay, don't write it down in case it gets too difficult, so just watch for a moment. The C is... I know this is going to be terrible. 1 over C equals C1, C2, C2 plus C1 when you add these together.
Yeah.
So C equals C1, C2 over C1 plus C2 if you flip them.
Okay.
So this will be C1, C2 over C1 plus C2, V1 plus V2. Do I want to continue? No, I don't want to prove this. I'm sorry, I won't prove it.
We try.
Yeah. I don't feel like I have the energy to prove it right now. I'll just give you the result. Okay, so if this one has charge of Q1 and this one has charge of Q2, this one has charge of Q1 as well. In other words, the total charge is equal to Q1 is equal to Q2. So it's kind of weird, but the charge here must be the same as the charge here when they're in series. And the total charge for the two of them together is the same as each one. It's a little bit like what? A little bit like the voltage, isn't it?
In parallel.
Yeah. Do I want to do the proof? She wants the proof. I'm thinking I would like to do the proof. No. It's good to see these things, Mayor. It's good to see these things.
If you can prove, I can understand.
Yeah, exactly. Right. Okay, we went with C1 equals Q1 over V1 and C2 equals Q2 over V2, and then 1 over C equals 1 over C1 plus 1 over C2. Yes? But C1 is Q1 over V1. So this is Q1 over V1. And then C2 is Q2 over V2. So 1 over C equals V1 over Q1 plus V2 over Q2. Now, here we know the voltage adds when they're in series. So we have Q equals, C, no, I'll just delete this because this is what we're trying to get to, so don't confuse me. C equals Q over V. But what is V? V1 plus V2. So then here this is 1 over Q over V1 plus V2. That's equal to V1 over Q1 plus V2 over Q2. Oh no, this is going to be bad. No, actually I think it'll be okay. V1 plus V2 over Q equals V1 over Q1 plus V2 over Q2. Yeah, easy. So we have V1 over Q plus V2 over Q equals V1 over Q1 plus V2 over Q2. Now when you look at this, you have V1 over Q plus V2 over Q equals V1 over Q1 plus V2 over Q2. The only way this can be true, the only way this can work, is if this and this and this and this, they're all the same. Now of course Q and Q are the same, but we're saying that Q must be the same as Q1 and Q1 must be the same as Q2. So we get Q equals Q1 plus Q1 and also equals Q2. So the total equals Q1 plus Q2. Now I told you it wasn't going to be easy, and I was thinking about not doing it, but some people wanted to see it, and this is good. So we have the, can I fit it in? Oh my goodness, okay.
You can take the common V1 plus V2 and then...
No, it's a little bit like saying, if I draw a comparison here, if I had, I don't know, 2 over a thing plus 3 over a thing equals 2 over a thing plus 3 over a thing. These all have to be the same.
Because it's equal.
It's because it's equal. It's like you're I'll give you another example, an easier one. Look at this one. If I said mx plus c equals 2x plus 3, what's the m? 2. And what's the c? 3. Because you're making a comparison on the left and the right because of the equals. So you're doing the same thing. You're saying that this q must be q1 and this q must be q2. So you're saying q equals q1 and you're also saying q equals q2. So q must equal q1 must equal q2. Don't you feel better for knowing this?
Yes.
Yeah? Okay. Since I've done it, you can write it down. Yep. Yeah. I know Fuang likes this proof. You liked it, didn't you?
Yeah.
Yes, I thought so. You don't like it. Yeah. You don't need this proof for the exam. You just need the results.
You said there were 3 proofs. Yeah. One was the UVATS.
UVATS, then Kepler is the other one, that's in semester 2. And then there's a third proof in semester 2. Yeah, so actually for semester 1, the only proof you need that's on the syllabus that could be on the exam is the UVATS. Now, interestingly, they've never asked students to prove this in the exam, but it is listed in the syllabus as one of the things that you might need to prove. The other 2 proofs, actually, sorry, I misspoke. The second proof is in this chapter, electricity, and the third proof is in a chapter in semester 2. Yeah. Now, they won't ask you to prove, I don't think they will ask you to prove UVATS, but technically they could because it's in the syllabus. But I won't ask you to prove it either in the end of semester exam.
semester 1 and semester 2 exams, do you make them or?
No, just the semester 1 exam.
You make.
Yeah, because it's only 10%. The final exam I don't. Okay, continue. Yep, alright. So we have now the result that Q equals Q1 equals Q2. And that's it for series as well. So let's have a look at an example where we combine capacitors. Yeah, we just have the one example. So I will, let's see, what have we got? A 100 millifarad capacitor is connected to a 200 millifarad capacitor, and these are charged using a 10 volt battery. So the first one is they're connected in parallel. So first draw this, and then I'll draw it. So I want you to draw this circuit. You understand? Yeah. Okay. Draw. What's wrong, Tuan? What? I want you to draw.
Honestly, it's a capital. Capacitor.
What's a capacitor?
Yeah.
What's a capacitor?
Yeah, but.
Oh,
it's
Tuan, you
wrong.
break my heart. A capacitor. This is the picture.
Oh. I think it's Q.
Q. Q is for. I sometimes write the Q beside it. Hang on. I mean, if I go back, I'll show you. Sorry, did I not show you the symbol? Did you not see the symbol? Yeah, this is the symbol. Capacitor you draw with two lines. Is this what you mean?
Yeah.
Okay. Right, so we have, let's look at this one now. Is it series or parallel for the first one? Parallel. So we have, is it battery or cell? Battery. 10 volts. Sorry, what did you say, Iyad? It's parallel, is it?
Yeah.
Alright, so this is what we should have, and this one is 100 milli and 200 milli. Right, what's my next question? So that's part A. B, what is the total capacitance? Okay, what formula do I need here for total? How do they add? Do they add directly or do their reciprocals add? Do you remember reciprocal, Fuan? You know this word? Well, actually, I don't think anybody remembers.
Reciprocal. 1 upon like.
Yeah.
Inversely.
Yeah.
This-
1 over C, C over 1.
This is called reciprocal.
Yeah.
When you flip it,
When you flip it, reciprocal.
How can you?
Yeah, good question. I don't know. I'm
R-E-
trying.
R-E-
R-E. Hold on, don't confuse me.
P-R-O.
Wait,
I know it.
wait,
I
no.
know the spelling.
Are you sure?
Alright, fine. Go ahead, Mir.
R-E-P-I-P-R-O.
wait.
P-A-L.
no, it's wrong.
P-I-P-R-O. No, P-R-O.
Yeah, he's right.
Oh, reciprocal.
That's right, yeah.
Reciprocal. Okay, good.
Reciprocal.
Yes.
Reciprocal.
Yeah. Hang on. Reciprocal.
Reciprocal. So it's P, please.
Yeah, P.
Oh, not pro.
Like he is saying in his accent. I mean,
My accent.
He say reciprocal.
Yeah.
Reciprocal.
Yeah. It's a different accent. Like, for example, I say electricity and Mir says electricity.
Yeah.
Yes.
Then, like he reciprocal. I say we say reciprocal.
Yeah.
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 No, I mean the pro.
Stephen! Come here.
English lesson.
We'll get him to say it.
Electricity?
Electricity? No.
Electricity?
That word.
Reciprocal?
Yeah.
Reciprocal.
No, he's right. He's right. Fuang doesn't like how I say it.
How do
No,
you say Paul?
you said
Now go on, say it.
reciprocal. So the pre is E, not.
Now, Stephen, you say it.
Reciprocal.
Yeah.
Google was.
Yeah,
So, do you prefer his or mine?
same. Yeah, but I mean, Y is O, not E.
Yeah,
Reciprocal.
Irish accent.
Yeah.
Yeah.
Do you prefer reciprocal?
Preco.
This one is prickle.
Yeah, pre.
Yeah.
In
The Y
American?
is pro.
Reciprocal.
Pro.
You don't say pro.
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 Is better?
Yeah.
Okay.
The way, you know, the way some people say professional, whereas most people say professional, and it's the same, reciprocal. Pro.
So it's not pre.
Not
really.
free.
Or did you say like preco? Reciprocal?
I didn't say that, no. I'm not that bad.
I feel like you guys may be slightly off the point here with this. Is this fundamental?
No. It's. We like to focus a little bit on language from time to time. Yeah.
Can I take a picture for Instagram?
Oh my goodness. Yes. Okay. What are you taking?
This, I like to look at this.
No. It's.
Where's it gone?
What's happening?
What's going on?
Are you going to post this later?
I think I might, yeah.
Yeah.
Yeah, I have to think of something funny to do with that.
Yeah, okay, all right. Here, we can. Stephen, I already have the title for the picture. Pro versus pre. Yeah.
Oh, do you know what I can do? I have this new thing that I've discovered where you can take a picture at the same time. So if I take a picture of that, but also your face at the same time.
What? Okay. All right, let's do that. Right. So my question was, how does the capacitance add together? Does it add together directly, or does it add together as the reciprocal? which is it directly or not?
Parallel.
In parallel,
yes.
it's direct.
Yes.
So the total capacitance would be 200 millifarads plus 100 millifarads. So that is 300 milli. Okay, next part. Part C. What is the charge? Okay, so what formula do we use for the charge? Q. Did I ask for each or total? What is the charge held in total? I should have actually asked for what is the charge on each.
Yeah, it's after that.
Yeah, I don't know why I did it backwards, sorry. So here, let's get the charge on the first one. What's the formula?
QCB.
C1.
Q equals CV, isn't it?
Yeah.
So C1, V1. Now because they're in parallel, the voltage is also 10, which is good. And what's the C1 is, I'll call this one C1 and C2. So that's 100 milli, which is 10 to the minus 3. So what do we got here? Is it 1? Yeah, it's 1,
Yeah,
isn't it?
1, yeah.
So it's 1 coulomb. And then for the second one, no surprise here, it'll be 2. So what's the total charge? Do we add or not for this one? We do. So the total charge will be 3 coulombs. Okay, and then the last, is it the last one? Oh, A, B, C, yeah. What is the voltage on each capacitor?
Same.
It's 10, isn't it? It should be 10. Now you can check it. For example, V1 would equal, oh my goodness, what's the formula? C equals Q over V. So V will be Q over C. It should be Q1 over C1. Q1, what did I say it was? 100 milli. And C1, no sorry, Q1
1.
is 1. And C1
0.1.
is 100 milli, isn't it? 10 to the minus 3. So this should equal 10.
All 10.
Yeah. So it's true. Yeah. So the answer is the voltage on the first one and the second one will equal 10 volts. Okay, do you have that? Yeah. So what I want you to do next for me before we go to the next lesson is I want you to do this again, but this time in series.
Yeah.
In series now. Yep. Everything's the same, but in series.
Can you please open the section?
Oh no, all the details are exactly the same.
Oh yeah.
Everything's the same.
Have to redraw it.
Yes, you just have to redraw it, that's all.
Any about the question?
All the questions are the
Yeah,
same.
but I
Okay.
just want to know.
Okay, let's have a look. They're in series now. This is 100 millifarads, and this one is 200 millifarads, and then we have a 10 volt battery. So that's the diagram. Did you all get that? Yeah. Right, what will I do first? The total capacitance. So how do the capacitors combine here? Yes, very good. You made an adjective, nice. So we have 1 over C equals 1 over 100 milli plus 1 over 200 milli. That will be 3 over 200. So the capacitance is 200 over 3 millifarads. What's that? 66.7 millifarads. Is that right?
If I swap the 100 and 200.
Oh yeah, no problem, yeah. Right, next, let's calculate the charge. Is charge next?
Yes.
Yeah. So here is Q1 and here is Q2, and we have the formula C equals Q over V, so Q equals CV. Yes?
Yes.
Now watch carefully. I want to know the Q1 and I want to know the Q2. Yes, they're equal. Do I know what the C1 is?
Yes.
Yes.
Yes. Do I know the V1? No, I do not. Do I know the C2? Yes. Do I know the V2? No. So instead of using this, I should use the fact that Q equals Q1 equals Q2. And I should look at the total instead, because they're all the same. We know that Q equals CV. Do we know the total C? Yes. And do we know the V in total?
Yeah.
Yeah. So my answer for Q1 and Q2 and Q is equal to 66.7 times 10 to the minus 3 times 10. What's that, please?
6.7 coulombs.
203.
6.67?
6.7 coulombs.
Huh?
Are you sure?
No,
0.7.
203. Oh, five.
Multiply 10.
Oh, 567.
I got something.
I'll,
0.67.
hang on, I'll do it myself in my head. Right, 66.7 times 10 to the minus 2.
Yeah.
1, 2.
Yeah.
0.667.
Yes, I got it.
Okay, great. Coulombs. And Fuan in millicoulombs?
7.
667. Good. Yeah. Right. What's the
I
last?
don't get the point. Why?
What do you mean
I
why?
get the capacitance my capacitance is 0.67 farad. Okay. it's
Did
not-
you flip it?
Yeah, I flipped it. I mean, it was 1 upon C is equals to 15 at last.
Yes.
And then C is equals to 0.67 farad.
Yes.
So,
Or 0.67.
yeah.
1 over 15 is 0.066. That's the capacity.
I think it's done something wrong. Did you do 1 over 100 plus 1 over 200?
No, we converted first.
Yeah.
We converted first.
The 100 milli
Yeah.
into
But
0.1.
it's the same.
It's the same. Everything should work out the same.
You don't multiply your answer by 10 to the minus 3 because you already converted.
Oh yeah, you're converting twice almost.
Yeah, so you time it by 10. That's
No.
0.67.
Still,
It's 66.
look, it's 66.7 millicoulombs. I know it that if we convert it in farads, I mean, we cut the then the
Yeah.
answer will be 0.67.
Yeah.
But when it comes to the charge, C, so my C will be 0.67 multiplied by 10.
Okay.
0.67
Yeah.
multiplied by 10.
Yeah, so it's 6.7.
6.7. But I'm
Wow.
wondering if
I got the same answer.
Huh?
I got the same answer.
yeah, you're doing there's some mistakes somewhere in your calculations. You should get the same answer.
Wait, 1 over 15. Yes. It's 0.06.
Yeah, you lost a 0. Lol. Yeah. Mirror. Lols. Right. What's next? Oh yeah, what's the voltage on each? So we can have if Q equals CV, then V1 equals Q1 over C, and VC1, and then V2 equals Q2 over C2. But remember, Q1 and Q2 and Q, they're all the same. So V1 would be Q1 is 667 times 10 to the minus 3, and C1 is 100 times 10 to the minus 3, and V2 equals 667 times 10 to the minus 3, and V2 is 200. That's nice, they cancel for me, so I get 6.67 volts and 3.33 roughly volts.
Yeah. 365. Yeah.
Yeah, roughly.
Yeah.
And what's great, what happens when I add these together?
10.
As I should.
Yes.
What's wrong? This is great, what's wrong? What? Can I continue?
Yeah.
No, what's wrong, Fawn? What? Something's not right. I need a question, Fawn. I can't help you without a question. Why 0.1?
Because 100.
Oh, you converted. Oh, I see. Yeah, this is right. This is 6.67.
Ah, yeah.
Right. Okay, we'll start the next lesson, but these are your questions for next time.
Okay.
These really, they're not that difficult. You're just using basic formulas here.
Can I? Okay.
If you want to take a picture on your phone, go ahead. It's on Moodle though. I'm going to close this in a second and start the next lesson. Yeah? Okay. Next lesson?
Yeah.
Yep.